All right, back to homework, section 4.1, and this is number 10. We're on the home stretch. We got 5 left. For the polynomial function below, they want us to do a couple of things. Let's write down the function first. We got f of x equals -7 times x minus 3 times x plus 6 squared. Now, the beauty of this is that they gave it to us in factored form. The factoring is something we'll do after the fact. So part A says find any real zeros. Real zeros means anything that doesn't have an I in it. Okay, so to find the real zeros, the first step would be to factor it, which of course it's already done, and set every factor equal to 0, because the zeros are in fact the values of x that make the value of the output of the function f of x equal to 0. All right, by the zero product property, we set the whole function equal to 0. And the only way that that'll happen is if each of the pieces of the product can become 0. Well, -7 cannot magically become a 0. So the first one that we're concerned with has a variable. So we can solve for x minus 3 equal to 0. The next factor, x plus 6, which shows up twice because it's got an exponent of 2. Well, you only have to solve it once, right? So we'll set x plus 6 equal to 0 and solve these very nice, quick and easy linear equations. That's why the factors are called linear. And we have 2 zeros, 3 and -6. Now, I'm going to write this down while I'm at it. The multiplicity of the x equals 3, 0 is 1 because it only showed up in a factor once. But the multiplicity of the -6 will be 2 because the factor that it came from was in the polynomial twice. All right, so find any real zeros, select the correct choice. So the real zeros of f are 3 and -6. Use integers or fractions. So it's possible that, you might end up with a fraction, 2/3 or something, that's fine. All right, part B. Let me scoop this up. Oh, the multiplicity of the larger 0. This is the part where you got to be super careful. The larger 0 is not the -6, folks. Number line. Oh, here's 0. 3 is over here someplace. -6 is over there. This is the larger one. Negative numbers are always smaller, right? So the multiplicity of the larger 0, which is the 3, is 1. And the smaller 0 is 2. All right, part B, the graph. Determine whether the graph crosses or touches the x-axis. Okay, so x equals 3 as a 0 will produce an x-intercept. The graph, in other words, will cross the x-axis at 3, 0. It has a multiplicity of 1. 1 is an odd number. If you have odd multiplicity, then your graph will cross the x-axis at that x-intercept. If we look at x equals -6, that 0 will produce an x-intercept. The graph of the polynomial function will pass through the x-axis at -6, 0, but that one came from a 0 that had a multiplicity of 2, and 2 is an even number. Even multiplicities give you x-intercepts where the function will just touch the x-axis and then keep going. So in other words, like if this was the x-axis and here's the x-intercept, you could have that happen, where the function goes off and does something else. It just comes down, grabs it, and then goes back up. Or you could have one like this, where it comes and grabs it from the bottom, and then it keeps going in both directions. Crossing the axis would look like this. So either coming from the bottom and going down through the, coming from the top, and going through to the bottom, or vice versa, something like that. So that's crossing. And this is touching. Crossing happens if you have odd multiplicity. Touching happens if you have even multiplicity. Okay, what else did they want us to tell them? If larger intercept was the 3, it will cross. And the graph will touch for the other one. All right, the maximum number of turning points. Turning points are where the graph, does like the maximums and minimums, like on the roller coaster. So I gave this one 1, 2, 3, 4, 5 turning points. The maximum number of turning points is always 1 less than the degree. So max turning points equals degree minus 1. All right, so we were given a polynomial that if you multiplied all this out would be an x cubed. So it is a degree 3 polynomial, which means our maximum number of turning points for the graph of that polynomial, if we were to graph it, would be 2. Remember, it's maximum. Doesn't mean it has to turn twice, but that's the most number of times it can turn. So maximum number of turning points is 2, and the power function that the graph resembles. So now if you, like we said, if you multiply all this stuff out, you would end up with an x cubed. So this thing will behave like the power function x cubed. Actually, get a -7 as our leading coefficient here. So this is going to behave like the power function negative x cubed. So if x cubed looks like this, right, then -7 is going to flip it upside down and stretch it out a bit. So, something like that. Now, all this stuff in the middle is going to be all the x-intercepts and y-intercepts and all of that. So the end behavior is that. This is the blah, blah, blah that happens in the middle, but these are the ends. That's what they're talking about, end behavior. Now, if I was standing in front of you, I would have one arm up and one arm down and be in the middle doing the blah, blah, blah. So type the power function that it resembles. Don't forget the leading coefficient in there. And that's it. I think the rest of this is all the answers. Determine the end behavior, the power function, yeah, that's it.